Now we are going to see the problems on electric circuits. So first of all, we will see some MCQs and then after we will move towards the structural problems. Now you can see the question number 1 here. The circuit shown includes 2 meters. Meter means any device which can measure the any physical quantity like current, voltage, resistance, etc., etc., etc. So there are 2 meters like X and Y connected correctly. Okay. So you can see this circuit and which row shows the unit of the quantity measured by Y and the unit of quantity measured by this measured by X and this is measured by Y. So you can see in this circuit 2 meters are connected. This is the X meter, this is a Y meter, and this is connected across this cell, and this is connected across this resistor. And you can see what kind of connection is this series connection or parallel connection? So you can see this is nothing but the parallel connection. Here for reference I have shown one diagram. You can see this is the ammeter which is connected in the series in this circuit, and this is the voltmeter which is connected in the parallel in this circuit. So we need to first understand which kind of meter it can be, and in the options the not meter is given but the unit of that physical quantity is given which is to be measured by this meter. So first of all identify whether it is a series or parallel. We know that it is a parallel, and in parallel what can be connected, ammeter or voltmeter? You can see this is only voltmeter can be connected in the parallel. So there can be other meters, but in the scope of syllabus we will talk about the ammeter and the voltmeter. So this can be the voltmeter, this can be the voltmeter, and voltmeter measures the voltage, and voltage is measured in terms of the volt. So here you can see the option number 1 is the ampere. Ampere is the unit of the current, so this cannot be the answer. Option B is the ampere volt. So we know this can be only voltmeter and it can be only volt. That can be the answer. So option number D is only, you can say it is a correct answer. Only option number D can be the correct answer here. So remaining things cannot be answered because that includes the ampere, which is the unit for the current. Now we will move towards the next problem. The circuit shown contains 3 ammeters, X, Y and Z. We know that ammeter measures the current, and now the problem is which ammeter has the largest reading. Okay. So 3 ammeters are shown over here. We know the ammeter is connected in the series of form. It is nothing but shown over here. So which ammeter will be giving the largest reading? So we need to apply here Kirchhoff's first law, and you can see what happens. How we have to draw the currents over here, then you can understand which could be the highest reading. So current is starting from this positive terminal of the battery. This is a battery, and say current will start from here. Like current will start from here. It will move like this. So if I call this is a current I. So what happens, there is a junction, and we know at the junction current splits. So here some current will flow over here and some current will flow in this direction. So here I can say this is some current, this can be I2, and here this can be, I can call it as I1. So I is going to split into I1 and I2. This I call it as I1, this I call it as the I2, just for the reference. So I1 is flowing like this. So you can see the X emitter will measure the current I1, I2 will flow like this. So this Y will measure the I2. and both will flow like this, and both will, here the I2 will flow like this in this direction, X will flow like this, and at this junction what happened, both of them will meet again, and here they form the again I. That was our original current. Okay, so I started from here. At this junction it splits, it becomes I1, this, and this is I2, and I1 will flow through X, I2 will flow through Y, and both will meet here and they again become I. So I is the addition of I1 plus I2. So I can write here I is nothing but I1 plus I2. So which one is the largest current? Okay. We know that Z is clearly largest because it is the combination of I1 and I2. Whether I1 is greater or I2 is greater, whatever, but I is ultimately the addition of I1 and I2. That's why Z can be the answer, because it is the addition of both the currents. Now we will move towards the next problem. Now the third problem, we can read here. The diagram shows the part of circuit used to switch street lamps on and off automatically. Okay. And in the evening it gets dark. Okay. Which row shows the effect on the resistance of light dependent resistor, that is LDR, and on the potential difference across it. So you can see this is a circuit, and this is a one resistor, and this is nothing but the symbol for the LDR, which is nothing but the light dependent resistor. You know what is the light dependent resistor? We learned that it is a kind of resistor whose resistance uh, decreases when the light is falling on it. Okay, and resistor increases when the intensity of light decreases. So it is the situation which is given in the dark. You can see basically here what is happening. In the evening it is getting dark, because in the evening what happens is resistor increases. So we need to find out what happens to the resistor or resistance and the potential difference across this light dependent resistor. So in the evening, what happens? First of all, we know the resistance will go on increasing, okay? Because as the intensity of light increases, the resistance of the LDR decreases. Okay? So only you can see that there are four options, and here in the column 1 it is the resistance, in the column B it is the potential difference. So we know that resistance should go on increasing. That's why this option A and B cannot be the answer, because this is decreasing, decreases. So our option can be only either C or D, that is increases because resistance is increasing. Now here we will take the help of this law, which is written here for reference, which is nothing but the Ohm's law, which is V equal to IR. And we know that resistance increases. That means if the resistance increases, what will happen? The potential difference across the uh, LDR is also increasing. That's why our answer can be only option number D. The resistance increases, and since resistance multiplied by current is giving you the potential difference, the potential difference will also increase. Now we will move towards the next problem. Two meters are connected in circuit to measure the current in the component and the potential difference across the component. Which meters are used and how are they connected to the component? So you can see answers are given. The ammeter and the voltmeter are in the options, and we know this circuit is given for the reference. We know the ammeter is always connected in the series, while the voltmeter is connected only in the parallel combination. So which can be the answer here? You can see uh, first is ammeter in the parallel. So we know the ammeter, that is this one, can never be connected in the parallel, so this cannot be the answer. So here second one, ammeter in series for current and the voltmeter in parallel for potential. We know this is the answer because the ammeter is connected in series and potential difference meter, that is a voltmeter,